All right. Good morning to everyone around the world because it's morning wherever you are. But yeah, so let me talk about the last video I did. The last video was on use case 6, which is the big one. Use case 6 is something I really think anyone could do on their network. You be careful, don't ruin your network. But it has the most potential for things that I think you could actually experiment with, like even in the real world. So, use case 6, if we can jump to it here, is identifying driving factors for problems in the network. So, all you need to do is collect data from the network. So, you need to know the host names, the device types, the firmware that it's running. You need to know the optics firmware. If you're running fiber, you should know like information about like the SFPs, information about the modular components of your device. You should know about like configurations. Like there's different ways to configure like BGP and OSPF. The classic example for OSPF is for some configurations, I think OSPF version 3 especially, you can use network statements within the global configuration, or you can go on the interface subconfiguration level and apply it there. So that might be something to track as well. Is there some bug associated with configuring it in this way, and can you configure it in another way and overcome that bug? You know, that's the point of a large part of this use case in this book. What data do you need, and what makes sense to track? What about the IP address? Does that make sense to track? Well, not so much, because it's all going to be different. So it's not going to be meaningful if it was tied to this one IP address, because that's not a factor that will apply to other devices. So basically what you're trying to look at is there some kind of, I mean, it's stated very well. What you're trying to look at is the driving factors for problems in the network. So this could be a firmware update. This could be a new connection. Let's say new ports came up. Well, maybe there's some sort of problem on the device, or maybe the device was even designed. There are some devices that are designed to have regulated port densities where you can't plug in every single link into every single port. It's designed in a way so that the chips don't serve every single port for whatever reason. So yeah, all you need is to think about and you know, it's good to think about this anyway. You've got devices, you've got hardware versions, you've got software versions, you've got configurations, you've got operational conditions, you've got environmental conditions, and other factors as well. So thinking about those is great, even if you're just an intern or a junior. Like you're putting your head in the right place, which is good. And then, yeah, there's the needle in the haystack problem. You have a large infrastructure and you want to put in place mechanisms to improve your network and cloud SLAs. However, you cannot identify what are the factors that are driving those problems. So that's what use case 6 is all about. Of any use case I've read so far, this has been the big one for sure. All right, but that is complete. So we're moving on now to use case 7. What is the severity of this log message? Pain point. This one and the next use cases are all about natural language processing, for which network and clouds are a very exciting field of applicability. Unfortunately, like in other technology areas in machine learning, fortunately, like in other technology areas in machine learning, we can leverage research that has been developed in other knowledge fields almost as is. All right, and let me take a quick break. I'll be right back. All right, I'm back. I needed a dry mouth lozenge. All right. In this use case, we start to explore one very important source of data for any network or cloud infrastructure: log messages. Logs are one of the three pillars of observability, along with metrics and traces. And I thought traces were log messages. Um, let me let me get some more information about traces. So tell me more about traces. Aren't they just logs? Oh, right. Okay, so Python has traceback. Yeah. hmm Okay, and that's all I need to know. It seemed to have stopped outputting. That's okay. I don't know why it stopped outputting. And I was getting it back through the wrong output, but um, yeah. So it's kind of like a traceback in Python. It's more than just a log. It shows you something that a log does not show you. It shows you the thing that it shows you the entire journey or life cycle of a request as it travels through different components of a system. Syslog messages carry a severity encoded in the log string, but we are going to pretend that for certain logs, we may not have such severity established. And then that's just one of the three pillars is logs. We also have metrics and traces. And metrics and traces probably don't have the same kind of severity encodings as syslog messages. Syslog messages are pretty clear, but the other thing with syslog messages is it depends on the administrator to set that up properly and to make sure those severity encodings are meaningful. So if they misconfigured that, this might be a way to to overcome that. Syslog messages carry a severity encoded in the log string, but we are going to pretend that for certain logs, we may not have such severity established. The severity is important to properly assess whether an action is required for a certain log message. Therefore, whether it comes with the message or not, we need to classify all logs into some level of severity. The problem we try to solve is how to classify log messages that do not have such severity defined. Approach. As referred, we are going to explore a few natural language processing techniques that we have explained in the theory section of the book. We will use a dataset of logs that are already labeled with the corresponding severity to train some machine learning model that will be used for classification of future non-labeled logs. We will explore various algorithms for that. In light of the availability of the so-called large language models, or LLMs, we will also explore how we could use them to classify the severity of logs automatically using zero-shot classification. We will explore as well how a cloud hosted LLM like ChatGPT can provide jaw-dropping responses and the potential this and future ones may play in the management and operation of network and cloud infrastructures. At the end of this use case, you will have a view on how to run classification algorithms for sequences of text and how to do one-shot classification with some large language models. Input data. We will use SANS to generate log messages. As part of the event policies and incident policies, SANS generates events, some of which can be syslog messages. Syslog message templates can be defined so that SANS will generate the text of the message out of such templates, replacing certain variables. We will generate log messages for a period of 1 hour for all PE devices from vendor Juniper. Feel free to change that criteria and try with other devices from the simulated environment. As in all previous cases, we have a preloaded dataset in a CSV file, logclassification.csv, for convenience. Feel free to use it or generate new logs using the SANS method. Alright, so let's try generating new logs. The problem with that is it takes too long. So we'll give it some time like we did before, and then ultimately use the pre-generated one if it takes too much time. The resulting data frame will look like the following. So it's the events DF data frame. And let's get that going and then move on to the problem resolution. So I have to open up Visual Studio Code, and then I did my last video, I did a code review for a volunteer project I'm on. And so I changed my workspace, so I'm going to change it back. There we go, nice and easy. And then, and you notice the virtual environment's already open. There's a pop-up that comes up asking about virtual environments. If you click yes on that, it will automatically open it to it. So we got a problem here. Stationary is not defined. That's just with the author's code. So we might see this eventually by the end of the book. So that's just something to be aware of. But for now, we're moving on to use case 7. So you know what? Let's actually commit these changes. So if we do a get history, if we get a log -1 line to see the history. So get log -1 line. Now we can see the history of the commits. Well, we could if there weren't some issue with my computer. I don't know what's going on. Okay, well, let's try closing it, okay, and then reopening it. All right, and we're still open to that same location. It's starting subsystem for Linux, Ubuntu 22.04, and it's taking a long time. So let's see if we can get some more information. No, it's just taking a long time to start WASL. I don't know what's going on with that. I've never seen this before. Usually it doesn't take this long. Let's try starting WASL here and see if that happens. So now so it seems like something is wrong with my Windows subsystem for Linux, which kind of makes sense because in the last video we were like in one of the last videos we taxed it like really heavily. But I did use it for that code review, so I don't know what's happening. A reboot of the computer is probably in order. That usually fixes problems like this. It looks like we do have a progress bar here, so the progress bar is almost complete. But yeah, a reboot of the computer will probably solve this because it looks like something got messed up so that starting the WASL is not working. Okay, so there's plenty of things I could do in the meantime. I think what I'm going to choose to do in the meantime while that's running is make some more progress in the reading. So the next section is problem resolution. We are going to focus only on 2 columns in this exercise, the message and the severity. Everything else that SANS has generated is not necessary in this use case. So there we go, log_df. And I heard a notification there, so let's go check that out. Okay, so VS Code server for WASL closed unexpectedly. Click WASL terminal for more details. All right, so let's close the WASL window. Okay, and then we're going to open a terminal. All right, and then open a open a WASL terminal here. Okay, and same deal. It's broken. So I think I think what I'm gonna do, I think a system reboot might fix this. So unfortunately, what we're at the 15-minute mark here. That's okay. I have some short videos up, so that's going to be it for this video. I'm going to restart, and then hopefully WASL will work then. So stay tuned for the next video where we go more in depth in the problem resolution, and then hopefully WASL is working and we can load up the notebook and get to this point. So yep, that's it for this video. Really short one, but I'll be right back.